Today it's time to go a little bit nuts. So a few weeks ago I was scrolling through social media and I came across a video of somebody making one of these by hand, and I thought that would be a great project to try and replicate on a CNC machine, and that is exactly what we're going to do today. Obviously ideal time of year because coming up to the festive period, for some reason everybody just eats a lot more nuts. So we're going to show you how to design this from start to finish and also get it cut out on your CNC machine. But the first thing we need to do is take a look at the material that we're going to use. Now when it comes to your material selection, do remember that as part of the process for cracking the nut, we've got to apply a fair amount of pressure to the device itself. So therefore you are realistically talking about hardwoods as opposed to softwoods, because I don't think they would withstand it. And also tighter grains give the material more strength. Now I've got a couple of pieces in front of me here. We've got some oak, some sapele or sapel, I never really know how to say, and also some purple heart. Now whilst the purple heart will look awesome, I actually think I'm going to be going with the sapele for this, and the reason is because when you coat this, if I just put a little bit of moisture on, it starts to darken it down and give it a deeper, richer colour, which I think is going to be ideal for this time of season in terms of the pieces that we are making. Now the thickness of it as well, probably around 1 inch thick is ideal for this purpose. Certainly nothing less than 3/4 of an inch, because we have got to put a bit of pressure and it needs to withstand it. So anywhere maybe between 18mm and 1 inch is going to be ideal, and that's exactly why I'm going to be using this piece of sapele right here. Now in terms of the bit selection today, we're going to keep this nice and simple and are just using the Downtown Jenny. This is a 1/4 inch down cut bit from Cadence Manufacturing. Obviously there are alternative brands, but Cadence Manufacturing make brilliant bits, and if you want to purchase them, use the code JamesDeanDesigns to get 10% off. Before we dive into Carveco Maker, a key feature on the nutcracker is obviously the pivoting handle. Now you can probably do this with a wooden dowel. I've opted to go with a piece of metal hardware like this. One, because I think it looks better, but also going to guarantee that it has the strength. Now these seem to go under lots of different names. I've seen them called Chicago screws, furniture board screws, sleeved bolts. Ultimately it is something that fastens on either end, clamping it together, that has a smooth inner area. And worst case scenario, you can technically just use a normal bolt with a piece of metal tubing over the top. Now when we get into Carveco Maker, I'm going to be telling you to machine a hole that is 8mm in diameter to take this particular bolt here. If you're using something different, obviously make sure you adjust that measurement to allow for whatever piece that you are using. Now the material I just had on screen is larger than it needs to be. To cut these parts out, you need a piece around 11 inches by 6 inches, so fairly small. Now I will also highlight, this is a CNC With Me project. If you're not familiar with that platform, it's basically a community for people with CNC machines where you can hang out, get ideas, inspiration, and also download weekly project files like this that you can follow along with. Now if you are interested, definitely check out the links, and the discount code JamesDeanDesigns will make you a saving. But the next thing we need to do is jump into Carveco and start getting this designed. So let's begin by showing what we are essentially about to create. We've got the two bottom parts here, which is the base with a recess cut out to take the handle. We've then got the handle itself with this bit of a ribbed edge going on, ultimately to help grip the nuts. Now there is a bit of dead space over here. We're not going to be using all the material today. It's just to give you an indication, say, of what we are doing. And then once this is simulated, it looks like this, and you can see the different parts that are cut out, including the ribbed edge. So let's create a new model. We're going to go new model. The size of my material is 460 by 168, and I'm going to leave the center as the origin for this particular job. Click OK and create that model. Now we're about to do some drawing. You technically can do this in the 3D view. I just prefer to do it in the 2D view, so I've switched over to that now. Now the first shape we're about to draw is the base. Now you can technically do this with the polyline, but I'm just going to do it with 3 rectangles and merge them all together. So we're going to start by creating one rectangle that is 180mm wide, a height of 25mm, and hit enter. We're then going to create a second one that is 50mm wide with a height of 25 again, hit enter, make that permanent, and finally we're going to do one that is a width of 25 with a height of 85, hit enter, and make that permanent as well. Now we just need to align these up in the correct orientation and weld them all together. So we're going to select these two. We're going to go vector, we're going to go align left, we're going to go align bottom. Now remember, there are shortcut keys for these if you have not used them before. And then we're also going to drag this one up to the top right to create that sort of curled extended C shape. And you should end up with it looking like this. We're then going to select all three of those rectangles. We're going to go to vector, we're going to go to merge and weld them all into one shape. Now this is kind of okay, but everything is looking a little bit square at the moment. So let's soften some of those corners up. We're going to come over to the fillet vector tool and we're going to start with a radius of 10 millimeters. And we're going to click this one here and we're going to work our way around and just fillet some of these corners. Now I'm deliberately skipping this inner corner here and just going to the one on the far right, and I'll now explain why I'm doing that. This is where the nut is going to sit, and the average diameter of a walnut is around 30 millimeters. So what we want to do is shape this roughly to the same curve as the walnut. So we're going to give this a radius of 15 millimeters, obviously half of 30 millimeter diameter, and put that in place. Now it is actually useful to have a rough idea of the walnut, so I'm going to draw a circle in place as well. We're going to make this, let's say 30 millimeters, as I said, the average size of a walnut. Hit enter. I'm just going to put that roughly in alignment with that original fillet that we did. And you'll see why this is useful very shortly. But for now, we're just going to drag these two pieces out of the way whilst we draw the handle. Now to draw the handle, we're going to begin by using the star tool. Now the amount of points we want on the star is 20 points. And in terms of the first radius, we want the overall diameter of this star to be 32 millimeters. So we need the radius of that to be 16 millimeters. Now for the second radius, which is the inner one, we need this then to be 15 millimeters. And what this ultimately creates, if I zoom in, is a 2 millimeter offset between the high and the low points of the star itself. So let's click create and make that permanent. Now again, that is technically okay, but some of these points are looking a bit sharp, so let's soften them up a little bit. We're going to use the fillet tool again, and we're going to make the fillet radius 2 millimeters. I'm going to start with this point over here, going downwards, softening these a little bit. I'm going to do each one. I'll speed this up on camera to save you having to watch all the click, click, click. So what I have just done is soften all of the radiuses or the corners from the far left all the way around to about this point here. Now the reason we are doing this is because we're going to get rid of all of these points anyway, so there is no point in softening all of those. And we're going to be doing this next by drawing the handle. So to draw the handle, we're going to use the polyline. And what we're going to do is start at the point at the very top of this. You can see how the cursor changes to that square, and it basically means that it's going to snap it to the top point of that shape. So we're going to click there to begin with, and if I pull this out, you can see it is starting to draw the line. Now again, we could do this by clicking, but I'm going to use the dialog box on the right to enter these measurements in. We're going to start by doing the x-axis movement, which is basically the direction the cursor is now moving, and we want this to be a 180 millimeters long. So 180, hit enter, and you can see it puts that point in. Now the next one we want is to move downwards by 15 millimeters. So in the angle, we're going to type -90 to move down. We're going to move to the next box over, and we want that to be at a 15 millimeter length. We're going to hit enter, and you can now see it's drawn that. So we have those 2 points in. Now what we're going to do is bring this down and sort of finish it up around there on that point of the star, and it's automatically snapped to it, and then we can come back up and complete the shape. So what we have is this nice little taper going on the handle itself. Now what we can do is select both of those shapes and again merge them together. So we'll come to vector, merge and weld into one shape. And a bit like earlier, we can probably soften up some of these corners and ultimately just make this look a little bit nicer. So again, I'm going to use the fillet tool. I'm going to make this a 5 millimeter radius. I'm going to radius that corner there. I'm going to radius the one below it. And then we're going to come in and clean up this area a little bit. And we're going to do this using the node editing tool. So we'll start with this corner down here. What I'm going to do is hover over this point right here, right click, and we have this smooth node, or you can use the S tool as a shortcut. And that just adds this nice little bit of a radius, as I say, to soften it up. And we can move this about a little bit and just move the various anchor points ultimately to make this a much softer and nicer curve as part of the way that is going to ultimately be cutting. And We can zoom back out and we can come back up, and we don't need all of these points up here. So again, we can tidy this up a little bit. We're going to remain with the node editing tool and just delete some of these points. Now, if you hover over each point that you need to get rid of and press the D button, it starts to remove all of the various points that you don't need. Let's take some of these out. Now for this final one, I'm going to hover over it and I'm going to press the S button instead, just to give us a nice curve to finish this off. And again, drag the handles over just to soften this radius up and ultimately make it a bit of a nicer finish on that handle. So if we zoom out a little bit, what we end up having is this shape right here. We've got the ribbed edges to grip the nut itself. We've got nice rounded edges on the handle, again just making it all a bit softer. Then we're going to take this shape and we're going to drag it all the way over here and almost start to mock up what this is going to look like, and you'll understand why as I work through this process. Now you want the top of both shapes to align together, and you want to bring this in till it is somewhere around there. So almost the lowest part of the ribbed edge is directly horizontal with the walnut mock-up that we have in place itself. Now the reason we are doing this is to understand where the hole needs to go for the pivot point of the handle. If it was in the dead center of everything, this would almost just rotate and not apply any pressure to the walnut itself. So the hole that goes through the middle needs to be offset, so as the handle moves, the amount of pressure being applied also varies on the walnut itself. So we're going to begin by drawing a circle. Now the diameter of my sleeves are 8mm, so I'm going to make the diameter of the hole about 8.2 just to give it a little bit of an allowance. So the circle is now created, and as I mentioned earlier, we need to offset this from the center just to give it that pivot action. So I'm going to put this as an approximation, let's say there for now. Now obviously that was just a bit of guesswork, but what we can actually do is see the impact of where that hole is in regards to the rotation of the handle. So what we're going to do is select the handle. We're going to come to the transform or rotate tool, and what we can see is we have different colored dots. Now this green dot over here is the rotation tool, and this blue square here is the origin for the rotation. We click on that and drag it all the way over here and place the center of that in the middle of the hole. Now if we zoom out slightly, and as we start to rotate this handle, you'll actually see it's rotating on that blue square as opposed to the center of the shape itself. And if I zoom back in a little bit, as I rotate this around, look where the lines overlap at the bottom, and ultimately, so if we raise it up, there is no pressure on the walnut, and as it brings it down, it hits the walnut and presses through it. So this is ultimately how you can judge where that rotation point should be, or the hole that you are machining. So we're going to zoom out just a little bit and undo that rotation that we did, but that gives us an indication that it is in a good position. Now ultimately, the lower that hole is, the less pressure it's going to apply on it. Now there probably is some law in physics like the fulcrum point which dictates the best position that that hole should be for applying the pressure, but I'm happy with where that is sitting now. We're going to zoom out and just take a look at the whole thing, and we can then see it in situ. So you can start to see this coming together. Now we've got to create two of these bases to stick together, but we've also got to machine an area out for the handle to sit in between both of them. So we're going to do that now to get an idea of where that is going to sit. We're going to come in and use the circle tool. Now the overall diameter of that ribbed edge was 32mm, so I'm going to make the diameter of this, let's say, I don't know, 36mm. Click create. And what I just want to do is place that roughly in a position so that nothing is going to hit when the handle is rotating. I may even make this actually just a little bit bigger. The precision of this is less relevant. It is more just as a clearance for the handle rotating. So I'm going to leave that there for a second. I'm just going to show you what we did earlier with the rotation of the handle. I'm going to come back to the transform tool, and we can see it has remembered the position we want it to rotate on. Now if I drag this around, this is about the clearance on how high the handle can lift going up. We just see there on screen it starts to impact that crossover point, so basically the handle will go no higher than that, and when we bring it down it will go no lower than about that point there, which again is too low anyway because it's already starting to hit the base. So that just gives us an indication that that circle recess that we need to cut is in the correct position. Now this is all starting to look a little bit messy, so let's tidy it up a bit. We're going to click on the little circle, we're going to press Ctrl C, we're then going to select the handle, and we're going to drag these out of the way. Now obviously we've just got rid of the hole there, so we're going to click edit, paste and put it back in position. And what we can also do at this point is get rid of the walnut, because we now understand its purpose in terms of relation to the nutcracker itself. So now at this point, technically the handle is complete. We don't need to do any more work on that, but we do need to replicate the base part. So I'm going to select all of these lines here, and we're going to use the mirror tool. We're going to click on that, look at the little pop out, and we want this to reflect over to the right hand side. Now obviously we don't want these two parts butting right up against each other, so I will just drag that out for the moment and give it a little bit of clearance. Now if I zoom out, obviously we have a lot of dead space on this material and we want to try and save as much as possible. So we're going to bring this and just try and align them all a little bit better, so we're using most of the space but not necessarily all of it. And we'll move this handle over a little bit, and it should just now mean that everything has its own space to be machined out without interacting with all of the other parts, and we can still salvage a little bit of that wood on the right hand side should we want to. Now it's time to get the tool pathing done for this particular job. So let's begin by recessing out the two parts on the base. So we're going to take these big circles over here. We're going to come to the tool path for the area clearance option. We're going to leave the start depth as 0. Now the thickness of my material is 25 millimeters, and we want just over half of that. So I'm going to make this 12.6 millimeters, which should ultimately allow the handle to sit in there, but not with too much play. We're going to leave allowance and final tool allowance as 0, tolerance as the default, and we're going to load in the downtown Jenny, the 1/4 inch downtown Jenny. We're going to come down. Obviously for the purpose of this, I'm just skipping over the speeds and feeds. That is all relevant to your machine. And we're going to make the clearance strategy an offset, so it starts in the center and works its way out. And we're going to begin at the inside. I'm going to add ramping moves to this, and we're going to define the material thickness as 25 millimeters thick. We're working from the top of the material, so we will leave that as it is and click OK. And we're going to call this the handle recess. We're going to calculate that toolpath. For the moment, I'm just going to turn those toolpaths off so we can then select the 3 holes required for the bolt and the sleeve. Now, technically, we could machine all 3 of the bolt holes to the exact same measurement, but obviously on the base pieces, they need to start 12.5 millimeters lower. So what I'm actually going to do is select the one on the handle first. We are going to do this as a profile, and we're going to select inside the circle itself. We are going to leave everything as 0 and turned off. Now the start depth is 0. The finish depth is, I'm going to make this 25.3 millimeters, so it should just cut through the material itself. We're going to come down and select the downtown Jenny for the bit, the 1/4 inch downtown Jenny again. Leave all the settings as default, add ramping on, and we're then going to call that the handle hole. We're going to click calculate now. Now what I'm going to do is select the 2 additional holes on the base piece, and we're going to change the start depth from 0 to 12.5. It just minimizes some of the machining that is required. We're going to click calculate now for those. Those are generated, and finally what we're going to do is to select the 2 base pieces and also the handle itself, and we're going to get these cut out. Now we can leave this on the profiling tool itself, but instead of inside, we want to change this to the outside. We're also then going to turn on a final pass allowance of 0.2 millimeters. This just basically means that once it has done all the cutting, it'll do a final skim around the outside of everything that can just help clean it up. We want to change the start depth back to 0 because we're beginning from the top of the material. We're going to leave this on the downtown Jenny. We're going to leave ramping on this as well. I am not adding bridges because I'm going to use blue tape to hold this down, so we can leave that unticked. And we're now going to call this the profile cutout. Click calculate now. We can then simulate all of these. Come back to the 3D view, and what we can see is essentially we have exactly the same as what I showed you at the start of the file. Now when you come to export the toolpaths for this job, the joys of it, it's all been created with 1 bit, so it's nice and easy. But do always remember to leave your profile cut out to the last particular job, so we can move over to the CNC machine and get this cut out. So we are nearly set up and ready to go. I'm cutting this today on the Saint Smart Genmitsu 4040 Pro Max, which is an amazing machine that I just recently reviewed. Link will be up in the corner, and the full video will also follow this one if you are interested in watching it. Now, as I say, we've got the downtown Jenny bit set up and ready to go. We've got the centre marked on our material. My hold down method is blue tape and CA glue, and we're also using a Fox Alien dust shoe. Everything you see in my video, I will put links down in the description area so you can find them. But ultimately what we're going to do now is just get it set up on the zero and get this job started. The job is done, finished nice and clean, so it's now time to get all of this removed. I genuinely love it when I use blue tape and I cut through the material but not the tape itself. It just makes me feel like I've got everything spot on. So with all the parts cut, we still need to give it a light sanding down and obviously glue everything together and finish the wood off. But just to give you a quick demonstration, if I put the parts together, I'm just using a drill because it's easier to get it through whilst doing this demonstration. Slide that in, slide that through. And if we put the nut in place, you can see obviously it hits the nut before it drops down. So therefore, once we put pressure on that, it will crack the nut and job's done. Now when it comes to the hardware or the sleeve that needs to combine all of this together, you have a couple of choices. Obviously the heads on these are fairly thin, so you can just allow it to sit on the top of the material and it won't look too bad. But usually the best option is to recess it within this hole. Now we could have done this whilst doing the CNC machining process and ultimately, double-sided the job. But for 2 holes, it's quite a lot of effort to have flipped everything over and just machine those out. So what I would suggest is if you want to recess these in, because it is just 2 holes, use a drill after you have finished. Just drill a hole big enough, maybe make it 2mm deep, and that will recess straight in there. And that is exactly what I'm going to do now with these. Hole has now been recessed. I've put the bolt through just as a temporary fixing. We can place the walnut in position, push this down, let's see. Perfect. Walnut cracked. So the next thing to do is take this apart, get it all glued up correctly and clamped together, and then we can apply a finish. The glue up for these is nice and simple. Just apply a thin layer of glue, make sure everything is aligned well. You can always place the bolt through the holes to help with the alignment and then clamp together with sufficient pressure. These clamps are probably a little bit overkill, but I like the fact that they clamp down with parallel pressure and then obviously let the glue dry. And then once the glue is dry, we can obviously release these out of the clamps, take out the piece, push the clamps to one side, hopefully without everything falling over. And there we have the base part now completed. What we're going to do is just give it a little bit of a sand over, take off any of the sharp edges. Some of you may like to round these over. I do like crisp, clean edges, so I'm going to stick with those, and as I say, just give it a little bit of a light sand down. Once everything is sanded down, obviously make sure it is clean. Just do a dry fit with the handle again, just to make sure everything is fitting correctly. Obviously, once clamping it together, that may get a bit tighter, so you may just have to sand a little bit off. Now when it comes to finishing this is obviously a product that is going to interact with the nut, so it needs to be something that is food safe. A food safe oil, or I'm just going to use some board butter from a friend of mine. Now this is really easy to do. You just get the board butter. Ideally you want a lint-free cloth to apply this. Just take a little bit. Can sometimes need warming up if it's a bit firm like this is, and then just start to rub it in to the wood. And as we can see, it starts to darken it down, and also just give it a little bit of a protective layer. Now the joys of this as well, it will also act as a little bit of lubricant on the handle when we pin this back together. So I'm just going to go ahead now, apply this butter all the way around it. Once you've applied the finish, give it time to soak in, then come in with a clean cloth and just wipe off any excess residue, ultimately getting it ready for the end product. I should also point out I've applied a little bit of the butter to the sleeve as well, as I say, just to help lubricate it as the hole for when the handle is moving up and down. So with that complete, now let's see about getting this assembled. Hopefully this goes in nice and easy. As I say, it's probably a little bit tight after you've done the clamping. Just get it in, try and get this bolt through with everything aligned. Obviously we still need to put the bolt on the other end, but we can now see that everything is working as it should be. Now when it comes to applying the bolt for the other side, obviously this does move a bit, so you may want to consider something like Loctite to ultimately hold that in place. It's not essential, but something just to say, consider to stop everything coming undone as the handle moves and rotates. So that is our nutcracker complete. To be honest, a fairly easy project. You could even take this one step further by engraving names on the base or even on the handle, just for a little bit of personalisation. Now I do like to look back when I make projects and think, could that be improved? If I made this again, one thing I would probably do is try and factor in a little bit of a divot in the centre where the nut goes, just to save it rocking about every time you put a nut in there. But yeah, something potentially for the next time I do this. Now just as a reminder, the code James Dean Designs will get you 10% off CNC with me, and also the Cadence manufacturing bits if you are interested in them. But I do hope you found this video useful, and of course if you did, please give it a thumbs up and make sure you have subscribed. Thank you all very much for watching, and final thanks as always goes to my patrons. I appreciate all the support I get from you. I will see you all on the next episode.